chemical bonding. In this chapter, we are going to study about the meaning of chemical bonding, ionic bonding, covalent bonding, other types of bonds, oxidation and reduction, and valence electrons. In this capsule, we are going to study about chemical bonding and formation of chemical bond. We shall also study about ionic bonds and ionic compounds. Children, here is a quiz for you. Which of the two shells of an atom has greater energy, L or M? Answer: M shell. Which orbital in an atom is nearest to the nucleus? Answer: K shell. What is the maximum number of electrons in the outermost shell of an atom? 8 electrons. Neon atom satisfies the octet structure. What does it mean? This means that there are 8 electrons in its outermost shell. The atomic number of sodium is 11. What is its electronic configuration? 1s2, 2s2, 2p6, 3s1. Children, often we enjoy the beauty of nature, water, trees, etc. We also enjoy delicious foods like bondas, yummy chocolates, don't we? All these are possible because of formation of bonds between atoms. Now observe this video. Let us immerse an iron nail in a copper sulfate solution. After some time, you see that copper is deposited on the nail. The chemical reaction of this is CuSO4 plus Fe gives rise to FeSO4 plus Cu. We also know that during formation of water, two atoms of hydrogen combine with oxygen to form water. The chemical reaction is 2H2 plus O2 gives rise to 2H2O. Atoms react with each other due to the formation of chemical bonds. Now we know that in an atom, there are equal number of electrons and protons, and the atom is electrically neutral. Then why do atoms react in spite of charge balance? Let's find out. Let us consider the structure of a sodium atom. It has 3 shells, K, L and M. The penultimate shell is L and it has 8 electrons. M is its outermost shell and there is 1 electron. Hence, the sodium atom has 1 valence electron. So, the valency of sodium atom is 1. Children, recall that valency is the combining capacity of an atom. Now consider another element, say boron, whose atomic number is 5. Its electronic configuration is 1s2, 2s2, 2p1. Its valence shell has 3 electrons, so valency of boron is 3. Some elements exhibit more than one valency, and such elements are said to have variable valency. Examples are copper and iron, each have valencies 2 and 3. Now let us understand the role of valence electrons in bond formation. Look at the structures of hydrogen and sodium. Their valence shells are incomplete. Electrons present in the incomplete shell decide the property and valency of that element. Valence electrons participate in chemical reactions, forming new substances by forming chemical bonds. Chemical bonding is a linkage formed due to attraction between atoms. Children, let us define. A chemical bond is an electrostatic force of attraction between atoms that allows the formation of chemical substances that contain two or more atoms. Copy this in your book. Now answer this question. Atomic number of an element is 9. What is its valency? Answer. Let us write the electronic configuration of the element. 1s2, 2s2, 2p5. In the ultimate shell, there are 7 electrons, so valency of the element is 7. Now let us understand how these bonds are formed. Observe this animation. An electron from one atom is transferred to another atom. Due to this chemical bond, ionic bond is formed between these two atoms. Again observe this animation. Here an electron pair is shared between the two atoms. In this case also, a chemical bond is formed which is called a covalent bond. So the major types of bonds are ionic bond and covalent bond. However, there is another type of bond formed in metals called the metallic bond. Now let us understand how an ionic bond is formed. Let us consider the structure of sodium metal. Its electronic configuration is 1s2, 2s2, 2p6, 3s1. In its valence shell, it has 1 electron. Every element wants to attain octet structure of the nearest noble gas, that is, to have 8 electrons in its outermost shell. Here, for sodium metal, there are 2 options to attain octet structure. 1. It has to gain 7 electrons so that its configuration becomes 288. This is energetically not feasible. Another option is to lose 1 electron, which is energetically feasible. So sodium metal loses this electron. Sodium is now short of an electron, and so it is called sodium ion or anion. Its electronic configuration will be 2,8, which is the configuration of neon. Elements which give away electrons are said to have low electronegativity. Metals have low negativity and hence are electron givers. When sodium metal loses an electron, there is no balance in the number of electrons and number of protons. That is, there are 11 protons and 10 electrons. So it is excess charge of +1, and thus sodium becomes electropositive by losing an electron. Children, let us consider the structure of a non-metal, chlorine. Its electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p5. In its valence shell, it has 7 electrons. Here, for chlorine, there are two options to attain octet structure. 1. It has to lose 7 electrons so that its configuration becomes 2,8. This is energetically not feasible. Another option is to gain 1 electron, which is energetically feasible. So, chlorine gains this electron. Chlorine is now excess with an electron, and it's called chloride ion or cation. Its electronic configuration will be 2,8,8, which is the configuration of argon. Elements which receive electrons are said to have high electronegativity. Non-metals have low negativity and hence are electron takers. When chlorine gains an electron, there is no balance in the number of electrons and number of protons. That is, there are 17 protons and 18 electrons, so it is excess charge of -1, and thus chlorine becomes electronegative by gaining an electron. Let us look at the formation of sodium chloride. When sodium reacts with the chlorine, it gives an electron to become a positively charged sodium ion, and chlorine becomes negatively charged chloride ion. These oppositely charged ions stick together due to electrostatic force of attraction. Thus, sodium chloride is formed. Due to the electrostatic force of attraction, energy between the ions decreases and the molecule becomes stable. That is, Na plus Cl gives rise to Na plus Cl minus, or Na plus Cl gives rise to NaCl. Sodium ion and chloride ion in sodium chloride do not form a pair, even though we write the formula by ignoring the charges on them. Now look at the SPDF electronic configurations of atoms and ions. 1s2, 2s2, 2p6, 3s1, that is 2, 8, 1, plus 1s2, 2s2, 2p6, 3s2, 3p5, that is 2, 8, 7, gives rise to 1s2, 2s2, 2p6, that is 2, 8, plus 1s2, 2s2, 2p6, 3s2, 3p6, that is 2, 8, 8. Observe that both the atoms have now attained octet structure. Children, now let us define. It is a chemical bond formed due to the transfer of one or more electrons from a metal to a non-metal. This bond is also called electrovalent bond. Now observe this video showing the formation of sodium chloride. Children, here is another question. The elements P, Q and R have atomic numbers 9, 12 and 14 respectively. Which one? 1 forms an anion, 2 forms a cation, 3 has valency of 4. The answer is, let us write the electronic configuration of each of them. Observe that valency of P is 7, so it is an electron taker and hence forms cation. Valency of Q is 2, so it is an electron giver and hence forms an anion. R has valency 4. Children, let us summarize the points about ionic bonding. Ionic bond is formed due to the transfer of electrons from a metal to a non-metal. Ionic bond is formed due to the electrostatic force of attraction formed between the ions. Children, note this down and copy this in your notebook. An element which gives one or more electrons is called an anion, and the element which takes one or more electrons is called cation. Ions of the electrovalent compound do not form pairs. Children, copy this in your notebook. Children, let us know few of the ionic compounds. Silver nitrate, sodium chloride, cesium acetate, magnesium iodide, iron oxide, copper chloride, and barium fluoride. Remember that while naming an electrovalent compound, metal is written first and then the non-metal by adding IDE to it. Children, now think and complete this table with suitable answers. Here is one more question. Which one of the following forms an ionic bond? A. Magnesium iodide Mgi2, B. Methane CH4, C. Carbon dioxide CO2, D. Potassium hydroxide KOH. Answer: we know that ionic bond is formed between a metal and a non-metal. So the correct option is A, magnesium iodide Mgi2. Discuss with your friends and answer these questions. 1. Valency of nitrogen is 7. What do you mean by this? 2. Atomic number of aluminium is 13. What is its valency? Children, copy this down in your book. 3. Select a pair of elements from the following which are likely to form an ionic bond. Option A, potassium and bromine. Option B, hydrogen and oxygen. Option C, potassium and argon. Option D, helium and carbon. Children, copy this in your notebook. Four. Complete these statements. When an electron is added to or removed from an atom, the atom becomes a or an dash. An element which loses one or more electrons is called dash. Electronegativity of X is less than that of Y. Then X is a dash. Take these down in your notebook. Electronegativity of X is less than that of Y. Then X is an electron dash. The chemical formula of the product formed from the reaction between Mg or magnesium and O2 or oxygen is dash. Children, take this down in your notebook. Children, you have understood about the meaning of chemical bond, formation of chemical bond, types of chemical bonds. You have also learned the meaning and formation of ionic bond. You also understood about electrovalent compounds. The key words in this unit are valency, sharing of electrons, ionic bond, electronegativity, cation, anion.